Good morning and welcome to HopsWorks webinar on anomalous transactions. I'm your host, Nate, Head of Accounts in the Americas at HopsWorks. We also have Yogesh, our Head of Solutions at HopsWorks, and David, our Head of Data Science at HopsWorks. Yogesh will now walk you through how to scale your AI investments.
Thank you, Nate. Hi, this is Yogesh. Hi, everyone. So today, just going over the agenda right now. So we're going to talk about the business problem, which is the ML-driven system for anomalous detection. So we are going to go through some slides and showcase the actual demo, how anomalous detection can be detected, and why HopsWorks is the right platform for this use case. And then during the demo, we'll show you again, like using the HopsWorks system and a no-code solution, which allows you to build this kind of system without writing a line of code. At the end, we can do some Q&A. So just stay tight. Okay, so a quick background about HopsWorks. So let's understand why HopsWorks is here, right? So in a world where machine learning is increasingly driving your profits, companies are really turning to this kind of platform, a strong HopsWorks type of platform to build better and faster ML-driven applications and how they can deploy this to production, in a faster, cheaper way. So HopsWorks is the only platform right now which can give you better predictions. It can increase your team productivity, and also you are able to seamlessly move your models into production. So the whole purpose is to cut down your time to market, like in the sense of like building a model and pushing your model into production, and that's where HopsWorks contributes the most. So based on our experience and with our customers, we have experienced a gain of like 3 to 4x in terms of the productivity of the data scientists who are typically involved in building the models, and then including the DevOps engineers who are actually responsible to move the models to the production. So you can easily achieve this return on your investment in few months, couple of months, like 3 to 6 months. That's what our experience has been. So better AI, faster accelerated process. So this is a very high level view of a HopsWorks platform, how it is implemented in real world. So as you see, you have all your underlying data sources, which can be your operational system. It could be a data warehouse, it could be a data lake, and it could be even external system. So we can literally suck data out of any of your source system, which can be a traditional RDBMS or a file system or data from the cloud. We can also pull data in real time from any APIs, from external APIs, internal APIs, which goes into the training process. So what you see in the center is the HopsWorks platform, which allows you to basically pull your data, build your features, train your model, and then those inputs features are basically input to your model, right? And once the model is created, then we can also do the inference right in the same platform. So you don't. That's how traditionally people have been doing. But with the HopsWorks platform, you'll be able to seamlessly execute the whole process on a singular platform, and you will be able to do your predictions and then kind of integrate these predictions into your ML applications. So we're going to show you an accelerator, which is kind of taking this output and like then you can build workflows, you can take actions on these insights. All of this will be shown in action today. Okay. Moving on. So what really works all and that tool where you will be actually in a box environment. Once this is done, then you'll start building your solutions. And then once the model is created, you need another system or again a lot of coding to actually deploy that. So there are there are a lot of stops in between that you have to take in terms of building your complete applications. And also like different teams are working in their own paradigm, right? They are working in their own sandboxes. So all of this has to be integrated well. So it can really become very complex process to bring all your models and the features in one place. And you have to also maintain the consistency, right? It's not just about productivity, but also the consistency, the performance and all of it, and the accuracy of the model. So it becomes a very difficult task to do all of these in silos. And that is where HopsWorks comes into place. It's going to break your silos. It's going to bring all your feature engineering in one place so that people are not only building features for themselves, but they can also share the features with other enterprise problems that they're trying to solve. So you get a consistent and a consolidated view of your features, and in turn you get better productivity and increase accuracy. Okay. Um, so as you see in the left here, you have all these individual applications which are running in silos versus you have one platform where you can run all your applications on a single platform, right? So what's the outcome of this, right? The outcome is really the you get ML models which are better, faster, and cheaper. Everybody is thriving for it, right? When we were in the world of big data, we were looking for better, faster, and cheaper, but now it's about consumption of that data. So HopsWorks is going to make your journey of consumption very seamless and very consistent and very performant. I'm just going to be on the slide for a few seconds. You can take a look at it. But ultimately, we are going to go through more slides to describe how the HopsWorks platform is really engineered under the hood, and then how this platform allows you to build applications and go to production. So this is another view of how the whole stack of HopsWorks works. At the bottom, you see we use multiple technologies. You have a feature store, you have a vector DB, you have a model registry. We use Kserve, which is basically another open source platform for deploying your models. And then all of this is kind of well integrated within HopsWorks package. So in the middle, you see there is a HopsWorks platform. And then now you can start doing like different applications. So before you actually start building any end user applications, you want to make sure that your customers or accounts or like addresses are all resolved. You don't want to work on duplicate customers. So you can solve the dedupe problem or identity resolution problem before you actually start building the other applications. That itself can be done within the HopsWorks platform. We have the algorithms available to make it happen. And then you can start building these various applications from left to right, as you see. Today, we are going to focus on the anomaly detection, and especially we are going to jump into a fraud detection use case, because anomaly can be in anything, right? It could be right within the data that is coming in. So you can do that. Also, you can do it from the use case perspective. So our focus will be fraud detection from an anomaly perspective. Okay, so I'm going to hand over to David from here. He's going to run through some of the HopsWorks concepts, the platform, and how this problem can be solved using HopsWorks. And then I'll switch back and give you a demo of the same. To you, David.
All right, thank you, Yogesh. Now I will show how to build ML-based fraud detection system using HopsWorks machine learning stack. So why a fraud and why is ML-based? So fraud itself is a big problem for the financial institutions, because if it evades the surveillance system, you can get a large amount of fine from the authorities, and also impacts a reputation with the customers. Now, the legacy-based surveillance systems, such as rule-based systems, have a challenge to keep it up ever-evolving fraud schemes, and fraudsters are very good at adapting a new technology and developing a new schemes. So what is a rule-based system? In a rule-based system, basically, is predefined rules. For example, if you transact a certain amount of money to a certain amount of destination, or the activity is a certain frequency on a time unit, like a last hour or last minute or last day, it's the alert. Otherwise, it's a okay transaction. And transactions and these predefined rules become very large, and it's challenging to maintain it. And also, it's optimized to not miss anything. So investigators get hundreds of thousands false alerts, and it's challenging to go through it, because the investigation also is not unlimited resources. You need a skilled people to do this. So the machine learning approach is machine learning. You learn patterns in your data. So in terms of, it will differentiate if there is something anomalous in your data, or in the fresh data that is in your machine learning system. And if something is different, you can give an alert, and the investigation can investigate it further. So it's more a data-driven approach. Now, the challenge with the machine learning approach is that there's a couple of main challenges. First is regulatory-based, because the rule-based are regulatory compliant. And if you flag someone as a malicious actor, or the transaction is malicious, you need to be able to explain why. And if the institution doesn't explain why, then it doesn't do any good. Another big challenge is a class imbalance, because it's by default or by nature is the anomaly. So there is very few known transactions or malicious actors. So it's for the supervised learning that becomes challenging to develop a good model. Now let's take how can we address both challenges. First, let's take how can we do a class imbalance. So since this we did with our customer, and then a paper is published. So it's a generative adversarial approach to detecting anomalies. So the idea is that instead of doing a supervised learning, it's a semi-supervised learning. So you learn a distribution of what is the normal transactions or clean transactions. So you can basically train a generator and discriminator, and then they learn this distribution, what is the normal behavior, and you also train an encoder with the generator, so you can also differentiate if something anomalous happens, how different it is from the rest of the data. Now, this model also has the ability to first you show to the model what is previously known as the clean transactions, but it also has the ability to detect if you miss something in your previous historical data, it also detects something different or anomalous within that data set. So in the training architecture is different, and then when you do inferencing, you basically use the generator and the encoder. So when the transaction comes, which you want to score, it encodes and the generator reconstructs it. And if the difference is big, then you flag it as anomalous. Therefore, you can investigate further. Or if it's if the error is close to zero, then it's a normal. Now the problem.
Hey, David.
Yes.
You are able to see my screen, right? Just want to make sure I'm in sync. I'm on the decision support system, or do you want to share your screen? That's fine too.
I share the screen, no?
Okay, I'll stop sharing. No problem. Yeah, please go ahead.
No, am I sharing?
Yes, you're good. You're good.
So, all right. So then decision support system. So how do we do that? How do we use it in the financial system? And what we did it previously is that this is more like a decision support system. So if you have your rule-based systems that generates alerts or scores of your transactions, this is numbers we got from with our customers that rule-based system generated hundreds of thousands alerts, and then about 1,000 was reported to the financial police. So what we did is basically you take this you have it as a complementary solution. So you generate 100,000, and by regulation you have to go through them. Investigator has to investigate it. So then you basically prioritize these transactions that has to go through. So in that case, it's easier to go to 1,000 transactions instead of hundreds of thousands. And it's because it's a priority, you can get the most important alerts to investigate. So in this case, you evade a possibility to miss any alerts. And also in this case, you can also detect the newly evolved fraudulent schemes, and you can use in your rule-based systems. All right, so why HopsWorks? HopsWorks, you can use both batch and streaming, and then online and offline feature engineering. Also, it's compliant. You have security, etc. And then you have it both for data engineering and the data scientists, and they're serving all the stack together. So let's start with the features we provide. So we basically, HopsWorks is built for you to build the feature pipelines, training pipelines, and the inference pipelines. And the feature pipelines, we differentiate these three pipelines because they require a different knowledge and a different expertise, and they also have a different life cycle. You can ingest the data, your streaming data, maybe for transactions or a historical data, or maybe you have your warehouse data that you can mount it. So we define feature groups that are reusable entities, and the feature views typically for a specific model. Let's say transaction, if you compute daily transactions and place, etc., that could be reusable asset you can use in many different models, many different use cases. But then if you will join in many different features, you can select for specific for the use case. For example, in this case, anti-money laundering or a fraud detection for a card fraud detection. And then you can define a training data sets. So you can choose also your favorite language. Let's say if you're using Pandas or Spark. So HopsWorks is very open in terms of if you have something, your favorite tool to do a feature engineering, training, or inferences, you can connect to the HopsWorks. We also should make sure that everything is versioned, and versioning is we do a schema versioning and time versioning. So basically, for schema versioning, to make sure that your downstream applications is not affected. So you cannot do a schema breaking change, and also time travel to make sure that when you train the model, you can debug what happens between now and then. And in that case, you can retrain your model. So Hopsworks also make sure that you can put the guardrails to your data, so your models get the correct data. First, you can do when you ingest the data. It's we provide the great expectations, and you can define what is the expected value. For example, maybe you expect that your customer should not be more than 120 years old, or you don't expect that transaction should be less than 0. And in that case, you also can define how can you alert it. You break a pipeline or you get the alert in your favorite system. Also, you can monitor if the data changes, because data changes, distribution changes of the data and the model decays. For example, maybe new technology was introduced, or maybe before and after the COVID pandemic, it can be a different behavior. So you can define these alerts, and you can see if the model decays, when to retrain, and it's also by the domain expertise, you can define when is the time to retrain your model. Hopsworks also provides a full provenance. You can find out if which features was used in your models, and then which features are used in the feature views in the training. So you can track all the way around. So it's full provenance is provided. We provide both implicit and explicit provenance. It's also searchable. You can search a metadata. You can define which are the primary keys. So you can search a primary keys and PIIs, etc. So all the metadata is searchable in Hopsworks. So it is discoverable as well. Hopsworks also provides one of the best high performance feature stores. So there is a link below, and you can see a benchmark. So we can both for streaming and reading the data. It's one of the top in the class. And also, I wanted to show this one, the benchmark we did, the feature freshness. So if you're doing a low latency card fraud detection, the feature freshness is when your event is generated and when the model gets the inference. So with a certain setup, it's less than a second. And yeah, you can use the Hopsworks if you're on premises. You can deploy on premises, and we also deploy on all the common cloud providers. I will shortly show then how the UI looks like. So this is a UI can define here. I provided the 3 feature groups. That is the monthly aggregates. It's customer profiles, and then we also use the graph. We compute the graph embeddings. You can use basically graph database like a Neo4j to compute the graphs, and you then insert the feature groups into the Hopsworks. So then basically then you can investigate as a statistics, what is the correlation. Everything you can define as a data scientist, and then it's discoverable. And you also have like activity, how many data points were inserted, when, and if there was some validation. And in this case, we see that it succeeded. So then I would say, let me see how we. So here is the feature pipelines. So we compute a feature. As I said, we define 3 different pipelines. You can define each pipeline for its feature groups. We compute the transactions. This is basically how you can define in the Hopsworks. You connect the Hopsworks. You define the expectation rules, and then you define a metadata. What's the partition key, primary key, if you want to compute the statistics, etc. And then you insert it. So it's then the Hopsworks infers all the schema by default. So if what's the name and what's the type of the feature value, you can also explicitly define it. Then training, we train a GAN model here. I will send out, or I think Nathan already put a code for this demo. We compute we compute embeddings, and then basically define a model, our anomaly encoder. And then we also provide the model registry here. We go to back here, and the model is registered. Here is an anomaly model, and then we also deployed it already, so we can start it to run it. You can also start it from the API, which is provided here. You can, in the model, you can get either model by version or the best model by whatever. If it's a loss function, then you can want to get what was the model that had the less loss available. So these models, then you can do either by the batching, but in this case, if the application comes, let's say transaction and the customer, then you can score it. And then it will give a scores, and the score basically will be as a domain, more a domain knowledge. What is the score that you can define as the anomaly, basically. And that again, all of this one can be integrated from a different APIs, or you can use the HopsWorks to use end-to-end machine learning. But if you have anything that is favorite for you, for example, feature engineering or a framework or a model serving, HopsWorks again provides a possibility to connect from the outside or externally to the HopsWorks. And again, you can also mount if you have a feature groups or already computed in your let's say you have a data warehouse computed, you can mount external tables as well. So that's also possible here. And now I will hand back to Yogesh, where he can show how to do this on a low code manner. Yogesh?
Thank you, David. Can you still hear me? I was facing some internet issues. Are you able to?
Yes,
Can you hear me?
we hear you.
Oh, okay. So switching back now, so I'm going to talk about the solution now, how we have built the solution, the detecting anomalies in the transaction data using HopsWorks and Inferix. So Inferix is basically a tool, which is a no-code tool, which allows you to build your applications without writing with minimal coding and all through the UI. And what it does is basically under the hood, it is using HopsWorks to execute those models and store the models, build the features, etc. So let's take a look at it. So why Inferix? As I mentioned, so it's a low-code accelerator available to build, deploy, and monitor your ML models into HopsWorks. It also uses graph technology, which is Neo4j under the hood, which is used for feature engineering and some other algorithms which are very specific to graph technology. So you can build your applications 10x faster. HopsWorks is already making your journey easy. We are putting accelerator on the top of it if you want to do in a low-code fashion. So you can eliminate a lot of tools that I'm going to show you today. Instead, you can use one single accelerator which allows you to build your features, store your features, build your models, generate the predictions, workflow engine, and so on. So it reduces a lot of integration efforts and gives you more auditability. It's very easy to collaborate because everything is happening through a centralized tool and a centralized platform, which is HopsWorks. So right now, this slide is showing you how the accelerator is actually helping us build the solution. So it really starts from the top. So as you saw in the previous slide too, the first step is really to do entity resolution. So there is a module within the platform which allows you to do the entity resolution. Once that is done, then we can start profiling these entities, which could be basically your accounts and customers, right? So let's say you're resolving the customers, you can then profile these customers, which is like calculating summaries of their transactions and then accounts and so on. Once that is done, then we can do behavioral analysis using machine learning models. Again, you have to do feature engineering and build a model, and then once the model is created, you can generate the predictions in criteria. So we have a business which allows flows, you can build dashboards, reports, and so on. So I'm going to show you all of this in action. This is just a high-level overview of the solution itself. Now, if you want to do something this in more real time, because HopsWorks as a platform allows you to do both batch and real time, so you will be actually taking your data from the source system in real time using Kafka, which is using the Apache Kafka connector. And then once you bring the data in real time into, let's say, a graph database, Neo4j, then we can then just once your model is ready, then you can deploy those models in production using the HopsWorks platform. Once the models have done the prediction part, then you will generate the alerts. Now, using these alerts, what we can do is we can block a transaction that's happening in real time, or you can also create a case additionally so that the investigator can log in and look at the case management dashboard. So all of this orchestration is happening through the Inferix as a no-code tool. But under the hood, what we are using is the HopsWorks platform, which is making all this happen at scale. So let's switch into the demo. Okay, so this is the demo environment. What I'm showing you is logging you into the Inferix accelerator, which is the no-code accelerator. So once you log into the accelerator, you will have access to multiple applications depending upon your privileges. So this platform allows you to manage multiple organizations, multiple accounts, and under each account, you can do a complete user role privilege management. Also, you can build multiple applications which will use machine learning for building various models. So today we are going to focus on the anomaly detection. So once you log in, you're going to land onto a dashboard. This is a default dashboard that is available as a part of this application. Now you can use this tool to build your own apps. I'm just showing you a demo app which was built for another customer, which is an AML monitoring app. So AML is also a type of anomaly within your transaction. As I mentioned in the beginning of the call, there could be various use cases falling into this domain, but today we are going to focus on AML. So you can look at all the alerts, cases, how many cases are open versus the total cases. So these are the chart libraries which are available in this particular tool, and you can build any dashboard as per your choice or as per your business requirements. Okay, we have around like 15 to 20 types of visualization, all the way from basic scorecards to advanced network graphs and Sankey charts. Modules in the accelerator, there is a data management HopsWorks. So that's the data management part of it. Once the features are built, then I can go to data science and I can build my models. So I can look at the features that are available, and then I can also build a model. Once a model is created, then you can basically run the business rule to generate the scores. You can do alert generation and you can do case management as well. So what we'll do is I'll just show you one example of how a feature is computed. So let's assume that this app is already connected to my source system where my data resides. It could be Snowflake, it could be an on-prem database like MySQL or Oracle. So I can take a look at that data. So let's say I'm looking at fact transaction. So these may be all my transactions that are coming into the system. So I can look at all the properties or the attributes that are available in that particular table. Now this is the table which is in the source. Okay, I'm going to use this table to build a feature and store into HopsWorks. And you can take a preview of the data if you like. So that's like looking at a slice of the data. Just like my internet a little bit slow, you can look at all the data that is available. You can create histograms and so on. So the tool basically allows you to explore your data, like ingest and then explore. Okay. And if you also want to see how these attributes were coming in, I can take the data lineage. So data lineage basically allows you to track how data is moving within your system. So a good part about this tool is we are extracting the lineage of the whole application, what you're performing. In this particular case, I'm looking at a fact transaction table, which is receiving data from another data set. And this data set is receiving data from other tables and so on. Some of the data is also coming from the files. So this lineage can be used for troubleshooting purpose. It can be used for auditing. It can be exported out and put into some kind of enterprise data lineage tool. You can do that as well. Now, let's say using this data, I want to compute a feature. I want to build a new feature. So I can go to the formula. A feature is nothing but an input to the model. So how do you do it? Like you have some mathematical expression or maybe some summarization and so on. So in this particular case, I'm creating like a summarization feature, which is using a window function. It is looking at all the outgoing wire transfer, and then I'm rolling them at an account level. So for every account that the customer is holding, how many such transactions have taken place? How many outgoing wire transfers have taken place? So this is how you will basically point and click and create the whole formula. So this could be any SQL that you can do in the SQL world that can be done here. Now, if something is more and that user-defined function can then be integrated into this. So you can write your UDF into Python, you can write into Java or any other language you want, and then you can integrate back here. But if it is a very basic feature which can be achieved through a SQL expression, you can very well use the screen, and through point and click, you can achieve it. Okay. Once you build your feature, you can combine all those features into a data set, which is also called like a feature view within the HubSpot world. Okay. Now features into the HubSpot platform. So here, what I'm doing is, let's say I'll take a list page from here. Okay, so I'm writing a feature group here. So you will create a pipeline, a very small pipeline, which is your feature pipeline. So this is a pipeline which contains only one step. It's taking the data from the data set out of the Infosys platform and pushing it into your feature store. So the way this use case works is I'm receiving my data in Snowflake. Let's assume I'm reading my data from Snowflake in memory using Apache Spark. I'm computing my features, and then I'm storing those features into HubSpot. So this is like a one-step process within the Infosys platform, which allows you to write into the feature store. Once you write the features into the feature store, then certainly you can go into HubSpot and you can take a look at it. So while that is coming, so let's look at features. So here you will have the ability to create features if you like, and I can create models. So I'll show you one model which is stored within HubSpot. Okay. So this model is using an algorithm called gradient boost tree. So we have 40 plus algorithms available out of the box, and we can always introduce new algorithms. And these are all the features that are sitting in HubSpot, which are kind of mapped into this model. So what we are really holding is the metadata, and using this metadata, I'll be able to train the model and store the model artifacts within the HubSpot platform. It just makes your life easy in terms of building the applications on HubSpot. You can very well use the Python APIs that comes out of the box from the HubSpot platform. That's one way to do it. But if you want to accelerate your development, not only the ML journey, but also the overall application journey, then you can use Infosys as a tool for that. So this is the model. So what I'm going to do is I'm going to train a model now. So I have to map data to the model, right? So here you can see, this is the model I'm talking about. This is where I'm pulling my data from. This is the feed out of the feature store. This is my label column in the data. This is my ID column. And then I have all these features that I mapped. So I'm mapping my feature data to the model, and I'm training a model now. So obviously there are of course, there are so many other parameters you can tune while training the model itself. All of this can be achieved through the front end. You don't have to write any line of code here. You can do hyperparameter tuning. You can save your results. You can save the model itself back into the HubSpot. Okay. You can do sampling, you can do seeding, and so on. You can decide what is the split in your data in terms of the train and the test. So once you train the model, then I can take a look at the results of the model. So there is a HubSpot model here, which is already trained. So this is using gradient boost tree. The same model that I was showing you is using Python algorithm. It is having this is just on a sample data. It has around 53 features. And these are all the parameters that were used as a part of training the model. Once the model is trained, we can show you the feature importance. So now this is a very classic example where we are using HubSpot and Neo4j. So we are performing some feature engineering in Neo4j. We are generating 2 or 3 extra features. We are pumping them into the ML model as input. And then those features are, if you can see, the first 2 features, which are the most significant, is the community risk score and the number of degree, how many degrees you are away from a fraudster. So those features have made really their way on the top. They are the most important features. So using Infosys, you are able to collate your features, right? You're able to pull your features, some of the features from your warehouse or the data lake, which is Snowflake, and rest of them can also come from another world, which is Neo4j. You can combine these features, and then you can store these features back into HubSpot. I can look at the performance of the model that was trained on the HubSpot platform. So we give you that visualization, which allows you to see what is the accuracy of the model and so on, all the metrics. And then you can also look at the train and the test data. So what we did was we took the data, we split on it, like an 80-20 split, and what was the data looking like? I have a little bit of a slow internet. Similarly, you can do evaluation pipeline, which is nothing but the inference pipeline for prediction purpose. And then you can deploy a model. So once the models are created, you can go to the model deploy, and you can start deploying these models. So this is the area which allows you to deploy. Now, what if you want to keep a track of how these features were computed? If you want to perform a lineage, let's say. So I can go back into the same model here. in the training, and then I can say, show me the data lineage. And now I can see the lineage of it. So each of this is a feature. So if you see, click here, it says it's a feature which is coming from the feature store. You can see the name of the feature, some description, what is the data type, and this kind of shows you where is the feature data coming from. So this feature data is coming from this table, which is nothing but a data pod. So within the Inferix platform, any table, we call it a data pod. So obviously the features are really the derivative of your raw data, right? So the raw data is these data points, which is kind of pushing the data into the feature store, and then using the feature store, then we are building a model and doing the predictions and so on. So we show you it's a complete transparent platform in terms of how your data is moving at every hop. So even if there are like 10 hops within the system, we can show you a complete tree from left to right in terms of your data movement. I'll take a brief pause here in case there are any questions. Nate, are there any questions here at this point? Okay, so continuing to the demo. So now I'm going to show you how the pipelines are created within the Inferix tool, which are basically orchestrating all the steps within the HopsWorks. So we saw the first one, which was the creating the feature group. I'm going to look at the next one, which is creating a rule engine now. So, so what we can do here is this is a rule engine pipeline, which shows you to put into the HopsWorks store. Once the feature stores are created, they generate the prediction. So that's the first part of it. This is the part 2 where you take the predictions and create alerts. And these are all the alerting rules that we have created. And then we have generated the alerts and created the case of it. Okay. So using the same platform, now you can actually take action generator or the predictions that you have made. So management next. So now I'm going to show you how we. Okay. So I'm going to open this case. So we are looking at a case which is created on a customer. We can see the severity of this case. We can change the severity if we like. If I want to see the details of this customer on which the case is created, I can click here and look at all the details of the customer. And this is a very configurable screen, so you can pick and choose what you want to display. Then I can look at the alerts that are created on this case, and I can drill down into the alert. So I can click on this alert, drill down further into it. So in this particular example or this application, we are generating alerts at an account level and then combining those alerts and creating a case at a customer level. So we are kind of rolling up all the alerts that are generated for each of the account for a given customer and then creating one single case so we can investigate it better. So I'm looking at the account details right now since I'm looking at an alert. And now I can also see which rules were actually responsible to generate this alert. So I can look at all the rules that got triggered and all the scores that got generated. Now this is really an addition of the score. That's why you see the score is very high. But if you want, you can normalize this between a value of 0 to 100, or you can take a min of it or a max of it, or you can do an average of it. Okay. So the overall score, if you see, is up to 100 because this is already maxed out because of the higher scores. Also, I can do a link analysis. So here, basically, we connect to the Neo4j database and pull the graph out of it. So I'm looking at an account. So what I want to see that how many other accounts this account is transacting with. So here you can see that this particular account in question is transacting to the other accounts. I may want to look at this transaction details. I can right click and say show details, and I can look at all the details of the transaction. Okay. If I'm interested to see how the money is moving between the accounts, I can see this. So these are all the accounts which is moving money into this account, and it's like a consolidation. And this account is kind of further transferring the money into downstream accounts. So this gives you an idea how money is moving between various accounts. Again, just to reiterate, this platform allows you to build your application as per your needs. This is not necessarily you may want to see the application in the same way, but whatever your business requirements may be, it will allow you to build it out. I can put my notes, I can do documentation around the alert, I can generate notifications and so on. Similarly, if I go back to the case, I can do the same things on notes and documents. Okay. Now, let me take you to the workflow engine, which is another interesting part. This is, I think, the most important thing that any application would require, because generating features, building models, generating predictions is all great, but it's not great unless you can take action upon it, right? So this is the workflow which will allow you to basically create an end-to-end process, what needs to happen next, okay? So in this particular case, I'll just explain a few steps. What you can do here is, so this is one of the workflow that we created for our customer. Here, after the predictions are made, an alert is generated, right? Once the alert is generated, we are initiating a case on the alert. Then we are getting all the case details. And then we are assigning these alerts to a group of analysts, right? Because we don't know who exactly the person it should get assigned to. So we assign a group level, and the people who is working in that group, they can kind of auto assign to themselves, or they can assign to one another depending upon their hierarchy within the organization. So these steps, when you see like there is a human icon versus there is a service icon, a service icon means it's going to be an automated step generated by the system. If you want to have any kind of human intervention, so for example, when the case is assigned to a person, which is central examiner, the person will go and do the investigation and then take an action. Either the person can say, okay, I'm going to take some more time, or the person can actually pass it on to reviewer 2, which is like the next level. Similarly, the case can then go from reviewer 2 to reviewer 1 and so on. So it can keep moving. If they want, they can put it back to the reviewer 1. So it can also come from reviewer 2 to reviewer 1. It's possible. If everything looks okay, the case can then be closed. If it's not, it can be reassigned and so on. So these steps you can configure however you want. So we have a workflow manager which allows you to drag and drop and create these business processes. Okay. This could be for your customer analytics application if you're running a marketing campaign or an offer. This could be for your fraud detection if you're generating an alert for any kind of anomaly if you see in your transactions. Or this could be for, let's say a completely different use case that you may be interested in. Okay. So that's the last part. And now I think I already showed you the dashboard part. So that's already taken care. Let's take a look at how dashboards are created here. Okay. So there are various dashboards here. One of the dashboard that I showed you was the AML monitoring summary. This was the dashboard we already saw. So depending upon how many charts, visualizations you have on that particular dashboard is going to show you. But in this particular case, you can see there are multiple charts. There could be dashboard which are more interactive where you want to provide certain input. So let's say I'm looking at a customer 360 degree. So I can select a filter, which is nothing but a customer ID. Let's say I'll just pick some random customer ID. I can say search, and then I should be able to see customer information, what products they're using, if there's anything suspicious around that. So if you see here, I can see the personal information, the address, the account details, and any alert information. On this particular case, there are like various alerts available. Okay. So this is like a very basic dashboard that has been created for customer 360 degree, but you can you can create as fancy as you want, depending on your requirements. Finally, you can then create a pipeline as I showed you the pipelines, and you can do a batch scheduling of the pipeline. So the tool will allow you to schedule these pipelines to run on certain frequencies. Okay. We also have job monitoring. So everything that's running within this no-code tool can be monitored. So let's say if I was interested in my training, all the training jobs that are running in HopsWorks, I can see there are 38 training jobs available. Some of them are failed, some of them are successful. I can look at the failed ones. I can view this to see what is going on within this particular training. I can see what time it ran, how much time it took. I can look at the details, if any. If not, I can go to the logs. So this is behind the scene running a Python code, which is running in the HopsWorks platform. So I should be able to extract those logs out of that particular platform, right? So let me quickly look at another job here. And the logs. Yeah, so these are all the logs, the Python logs that you can see. So either you can use Notebook if you are programming into the programming world, you can write Python code, you can connect to the HopsWorks through the APIs, and you can see the logs right on the Jupyter Notebook. And this is another way that if you're using the low-code accelerator, we can show you the logs here as well. Okay, I think there is a question. The question we have here is, do we have telecom network anomalies or CX created use cases? Okay. So we have done a use case with one of the telecom company, a telecom industry, one of the largest telecom company where they wanted to do network simulation. Basically, they wanted to optimize the network. So we have used the graph technology, machine learning, and along with the Infox accelerator to build an application which allows the user to run different experiments and see if a particular router goes down, what is the impact on this particular network? Is it going to be better? Is it going to be worse? How the network can be rerouted given a particular router is down. So that is more like a simulation use case. We can, you can connect with us offline, and we can give you a deep dive into that use case as well. Yeah. Nate, any other questions for me, or I can just continue?
Yeah, will we touch on the knowledge management graph is another question that just came in.
The knowledge graph?
Yes.
Okay. So yeah, I'll spend a few minutes on this. So this is the last part, which is the knowledge graph. So as I mentioned, using this accelerator, you can design your own knowledge graph, and then you can store, read, write data out of Neo4j. So this is an example of a knowledge graph. This is a link analysis graph. So using this UI, you can actually configure the whole graph. So this is a small graph that I'm showing you right now, which contains branches, customer accounts, IP addresses, and so on. You can design your graph using the accelerator, and then you can define like what should be the color, what should be the icons. You can also put some intelligence around it. You can say that if this customer is residing in XYZ country, then you may want to highlight in red. So you can do highlighting on the top of it. You can control the size of the node itself. You can control the size of the. So if I double click here, I have a highlight option, so I can decide which column should be used or property should be used out of the graph to highlight a particular edge or a node. Now, you may have an existing knowledge graph. So there was a question in one of the demo. If you have an existing knowledge graph, how do you get started? So you have an option to infer. So I can basically click on the infer schema here. I can choose my data source, my Neo4j database. Click here, and then it's going to pull all the metadata out of Neo4j, all the nodes and edges, and then you can select them, and then you can start doing all the visualization within the Inflix platform. I can click this. Now, this is a graph that is coming out of the database. Okay. So one option is you can basically reverse engineer the graph that's already in existence, or you can build a subset of what you like to see. So your database may have like hundreds of types of nodes, but you may only want to see like 5 or 10 nodes because you're focused on your analysis on one thing. So you can create a subset from here, and then you can basically go to the next screen. You can say, I want to out of your source system, which could be file system, it could be databases, Snowflake, MySQL, wherever the data may be. It will run the transformations for you, and then you will write the graph into Neo4j. But if you have already your data into Neo4j, then you don't have to execute this job. You can just create this for visualization purpose. Okay, because sometimes you may be using scripting or maybe another set of tools to push your data into Neo4j. But very well, you can use this accelerator to even interact with Neo4j. So this is really a one-stop shop for building all your applications. Running more than 10, 12 applications using a single platform, which runs on the top of HubSpot, which runs on the top of Neo4j, and any traditional database you may have in your environment. So that's the knowledge graph part, and then you can look at the result and you can do the analysis. One, yeah. Yeah.
Hey, Yogesh, one question came in as well, which is, can you please explain in more depth what was done in regards to the network optimization?
Okay. So I kind of explained, right? In the network optimization, we have created a knowledge graph which contains routers and data packets and few other machinery that is used within the telecom world. And then we have run simulations on the top of it, like algorithms, the graph algorithms, to generate, to run basically various scenarios and see what would the network impact would be if this particular router is down. So we were kind of rerouting the traffic for network optimization and seeing the impact. And also we were kind of switching on and off certain routers basically taking a router out of the network and see if this router goes down, what is the impact of the network and how the traffic can be rerouted to make it more optimal usage of the available routers. Okay. I have a summary slide which I would like to share. Give me 1 second here. Yeah. Nate, can you still hear me?
Yes, your audio is much clearer now, whatever you just did.
Okay, thank you. So just to summarize, so just want to show you like, how this basically this HopsWorks and accelerator combination is working. As I mentioned, HopsWorks is the platform which allows you to do your feature engineering. So at a high level, there are 3 different pipelines. You have a feature pipeline, you have a training pipeline, you have an inference pipeline. So obviously, the goal here is to make sure that for this particular use case, which is anomaly detection and for fraud detection, you want to reduce your crime, and the overall cost, right? So how HopsWorks is really helping you to achieve this is basically through the singular platform to improve your bottom line, and then you can make better predictions, faster predictions, and you can have less false positives, right? At the end of the day, the lesser the false positives, the more easily you can catch the fraudster. Also, you want to make sure that you can stop this fraud in real time. So you have to be pretty fast at it. So HopsWorks has the online store, which is where you can read these features in real time in milliseconds, and then you can basically make predictions. So also you can do continuous learning. So this platform is not about just building your application once or the platform once, but you can retrain your model on a periodic basis, and you can have a continuous learning going on. So you can automate the whole CI/CD process where the feature data is changing, the model is getting retrained, and new predictions are generating using the new models. Okay. It's a faster time to value because now we are providing you an accelerator along with the HopsWorks platform, which makes your life easy in terms of using a no-code platform. Now you can build your applications through the front end, the whole feature engineering, the model training, the inference, and also the dashboards and the workflows, right? So you can run this on-prem, you can run it on the cloud. Both the options are available depending upon the situation you may be in. And there are always 2 options to build your models on HopsWorks. You can, if you are very Python, then you call our APIs. So in the Python APIs, you're able to build your models. And if you want to do a low code, you want to accelerate the journey of app Inference Accelerator, which sits on the top of it and track with other databases. Nate, any other questions, or do you want to add anything more?
There's no more questions, Yogesh. I don't have too much more to add. Do you want me to wrap it up?
Yeah, sure.
Thank you to everybody for joining in. If you need any more information, feel free to reach out to me on LinkedIn at Nathan Greenhut or at my email address, nathangreen.greenhut@hopsworks.ai.